We've been focusing on two aspects of carbon dioxide and water on the surface of Mars in recent years. The first is to understand a process which results in geysers or jets of CO2 rising out of the surface from underneath an ice layer, and this deposits dust material on the surface of Mars, particularly in the polar areas. And we've been trying to understand the phenomena associated with that. It turns out to be very complicated. There are lots of interesting structures that we see on the surface. Some of them are called spiders, and we can see how these jets and geysers, which can rise to 100 meters up in the air, we can see how these geysers help erode the surface and produce these spiders. The second thing that we're interested in is water, and whether there is any evidence for liquid water on the surface of Mars. In recent times, we've been using the high-resolution imaging science experiment, HiRISE, on the Mars Reconnaissance Orbiter to look at very specific areas on the surface of Mars. Some of them, like Newton Basin and Horowitz Crater, they show evidence of very thin, dark structures which grow with time during the summer months on Mars. We think this is evidence for liquid water because of the way that these structures are reproducible. They come back every year, and because of their location at very equatorial latitudes. We think also that because of the Martian surface has a lot of salts, things like iron sulfate or perchlorate salts, that these help in depressing or reducing the temperature at which water melts. And in this way, it helps the process proceed. We've been working on this together with our American colleagues from the University of Arizona for the past 4 or 5 years or so, and we've published a number of papers on this topic.